On a hot summer days, we know that the air near the ground is hot, and it is having a low refractive index, and it is low dense. So as we go up, we know that at higher altitudes, at higher heights, the refractive index may increase, or we can say that it is it is denser than the ground part. So you can say that the refractive index of the air varies according to this one. So we can say that as we go up, the refractive index can be assumed to be increasing. So when we consider a taller object like a tree or something, we can say that light from the tree will experience a refraction from a denser medium to a rarer medium. So it's a refracted light always bend away from the normal. So finally we know that as per the total internal reflection rules, we can say that it finally internal backs to reflected internally to the same medium. So we can say that there is a possibility to happen total internal reflection. So the light ray may be experienced a bending during its travel through the medium, through the air. So a person who is observing this light may see as it is coming from the it was coming from the ground. So we can see that there is a water body or something that is reflecting, reflecting on the ground can be observed in this case. So he may misunderstood that there is water in the ground. So this is a case of mirage. This is the case of mirage, and this phenomenon is known as mirage. That is usually happens in desert areas. Sometimes we can observe in hot day in our side also. If it is a long road, you can see that there is water in the ground, but when you approach the spot, you may observe that there is no water in the spot, in that spot. So this is because of the mirage. So all these phenomena are based on total internal reflection. Light sometimes goes to the reflection, undergoes the reflection. Next application is brilliance of diamond. As we know that the refractive index of the diamond is nearly 2.42. That is very higher than any other common object. So the critical angle, corresponding critical angle is very low. So most of the light incident higher than this angle will be considered as a total internal reflected ray. So the possibility is more to reflect the light inside the material. So we know that as light enters the medium, it will be in a denser medium. As it go out, what happens is it is traveling from a denser medium to rarer medium, and the possibility of reflection is very more. So that is the reason for brilliance of diamond. Next application is a prism, which inverts a light incident on it by 90 degree or 180 degree without any change in the size of the material, size of the object. So we can say that we can use any of these prisms shown in the figures, because the critical angle can be considered as less than 45 degree. As you know, the refractive index of dense flint glass and crown glass is less than 45 degree. So we can use those glass in for this purpose. So the only thing we have to consider is the specified angle should be the angle that is used to cut the material. So 45 degree, 45 degree, 90 degree. That should be the angle of the material. Then we can create a this type of materials, this type of prisms. Next one is an optical fiber. The application is used for sending of video signals and audio signals to a larger distance, so that we can use this this material to using total internal reflection. We send signals inside the material, so the inside material is considered as a high refractive index, so that we can consider that denser medium, and the other medium can be considered as a low refractive index medium, so that we can consider it as a rarer medium. So when it enters inside the material, it observes us it is in the denser medium, and it tries to go out to the rarer medium. So again here total internal reflection happens because of the arrangement of this material. So we can say that total it reflected back towards the same medium, so it can be transmitted light, it can be used to transmit light to a longer distance. So at the other end we can take it back without any loss of intensity. So that is the advantage of sending these materials, sending signals to into these materials and taking it out. So transmission loss is very less. We can send this to longer distances with a high clarity of the signal without any attenuation, we can say. So here the inside material is known as core and outside material is known as cladding.